The random variable x takes the values 1, 2, 3, 4 with probability 1 over 4. Two independent values of x are chosen at random. If the two values of x are the same, the random variable y takes that value. Otherwise, the value of y is the larger value of x minus the smaller value of x. We need to find the probability distribution table for y. So we need to find the values of y first. Two independent values of x are chosen at random. Let's say that this is the first x chosen and this is the second x chosen. It's easier to find the values of y this way. If the two values of x are the same, then the random variable y takes that value. So if the first and the second one is 1, then you have a value of 1 for y. And we have a value of 2 here. 3, 3 is a 3. And then 4, 4 is a 4. That will give you a value of 4. If the values of x are different, we just find the absolute value. A 2, 1 here, the difference is a 1. A 3 and a 1 has a difference of 2. 4 and 1 has a difference of 3. So a 1 and a 2 has a difference of 1. 3 and 2 has a difference of 1. 4 and 2 has a difference of 2. And 1 and 3 has a difference of 2. 2 and 3 has a difference of 1. 4 and 3 has a difference of 1. 1 and 4 has a difference of 3. 2 and 4 has a difference of 2. And 3 and 4 has a difference of 1. From this part, we see that there are 16 outcomes, each with probability 1 over 16. And that should give us the values of the random variable y. So these values here are the values of y. We see that the random variable y takes values 1, 2, 3, and 4. And now we can construct the probability distribution table for y. So we have y and the probability of y. Then you have 1, 2, 3, and 4 as the outcomes. Now let's look at the number of ones that we have. So we see that 1, 2, 3, 4, 5, 6, and 7. There are 7 ones. Then we have 7 out of 16 for the probability of 1. And then we need to find the probability of 2. So we have 1, 2, 3, 4, and 5. There are 5 values of 2. Then the probability that y takes a value of 2 is 5 out of 16. Then we look at the values of 3. So we have 1, 2, and 3. And this means that we have 3 out of 16 for the probability that y is 3. But there's only one miserable 4 here. So we have 1 out of 16. Make sure you check that your answer is correct. The denominator are 16. So you add the numerator. The numerator should add to 1 because total probability should add to 1. The sum of P of y here must be 1. Otherwise, something is wrong. Part B, find the probability that y is 2 given that y is even. This is a conditional probability. We find that the probability y is 2 given that y is even. So for conditional probability, we find the probability y is 2 and y is even all over the probability that y is even. Y is 2 and y is even. This is the intersection of getting a y value of 2 and even. Y value of 2 is 5 out of 16 here. And the probability that y is even. So for even, you have a value of 2 and a value of 4. So these two will add up to 6 out of 16. Then we divide by 6 out of 16. We have 5 out of 6.